Today we will consider this equation, and we find number of real solutions of this equation as function of a and k. A and k are positive. After that, we will solve several examples which illustrate all considered cases. We will start with observation that the left-hand side of equation is positive. Then it means that kx is positive, and because k is greater than 0, x is positive. Next, we introduce new variable z equal kx. We take x and plug in to initial equation, and this equation we will rewrite in this form. We take logarithm of both parts of this equation, use well-known formula of algebra, and here we will have this equation. We divide over z both parts, and we have another form of the same equation. We replace ln a over k with b equal ln a over k, so this equation will have a simple form where b is a real number. This equation is equivalent to this equation, which was considered in one of the videos on my channel. The title of that video is the following, and the link to that video one can find in description to this video. The number of solutions of this equation as function of b is given by this diagram. As one can see, there are cases of no roots, single root, and two roots. To get the solution of our equation, we need to replace b with ln a over k, replace x with z, and after that we will get solution for our equation in the form of diagram. The number of solutions of this equation is equal to the number of solutions of initial equation, because z and x are connected by linear dependence. So the problem is solved completely, and we can go to examples. In example 1, we consider this equation, and by inspection we can find immediately one root, which is equal 2. If we plug in here 2, on the left hand side we will have 9, on the right hand side we also will have 9. If we think that this is the only solution of this equation, we can make a mistake. We need to check if this solution is single or there is another one. To do this, we will apply what we got above. So we compare this equation with initial one, and we can see that a in this equation equals 3, k is equal 9 over 2, and parameter ln a over k equal ln 3 divided over 9 over 2 and equal to this number. Now we will call the solution for this equation, and we will see that because 1 over e is about 0.4, this value is between 0 and 1 over e, so it has two solutions. So there is another one solution in addition to this. We illustrate this considering the plot of left-hand side and right-hand side of this equation. Black line is y equals 3 to power x, and the red line is y equal 9 over 2 times x. As we see, these two lines have 2 points of intersection. First of them corresponds to root x1 equal 2, and second one is here, and we can find from this plot that this value is approximately 0.31. If needed, we can find the value of this root with higher precision. Now we can go to the next example. In this example, we consider this equation. Comparing it with our initial equation, we see that a equals 3, k equals 2, parameter ln a over k equal approximately 0.5, and on the diagram this value is on the right from 1 over e, which is approximately 0.4, and in this case this equation has no roots. We can illustrate this plotting left and right hand sides of this equation, and we see that these two lines have no intersection point. In the example 3, we will consider this equation where a equal 3 and k equal e times ln 3. In this case, parameter ln a over k equal ln 3 over e ln 3, or equal 1 over e. On the diagram, this point is here, so we have here a single root. Plotting right and left hand sides of this equation, we see that the curves which represent them has one intersection point, which is the point where one curve is tangent to another one. In this specific case, we can find x. How to do this? First, we return to our equation for z. We replace ln a over k with 1 over e, so we have this equation. This equation has evident root z equal e, and this is the only root of this equation. We recollect that z equal kx, so x equals z over k, or equal 1 over ln 3. Approximately, x equals 0.91. Finally, we will consider example 4, which corresponds to the case a equal 1 in our initial equation. So we have equation 1 to power x equal kx. We know that 1 to x is equal 1, so we can rewrite this equation as kx equal 1, or we immediately have solution x equal 1 over k. To double check this solution, we will apply procedure which was developed above. So we have a equal 1, ln a over k equal 0. On diagram, we are at this point, so we have the single root in this case. And this single root equal x equal 1 over k. Graphically, we can illustrate this solution if we plot left and right hand side of this equation. This is two straight lines which intersect in one point, which correspond x equal 1 over k. I would like to draw your attention that here is kx on the horizontal axis, not x. If you like this video, you may want to click like button, leave a comment and subscribe for the channel.